After learning about t-statistic and p-value, which tells us the significance of individual beta coefficients, we will learn about f-statistic, which is used to test whether the model as a whole is statistically significant or whether the independent variables jointly have no effect. F-statistic answers the question, does my regression model explain a significant portion of the variation in the dependent variable, or is the group of variables I am testing jointly significant? In regression, the F-statistic is derived from comparing explained versus unexplained variation. The formula for the unrestricted model is SSR divided by K whole divided by SSC divided by n minus K minus 1. Here SSS is equal to sum of squares due to regression, SSE is equal to sum of squares due to error, K is equal to number of independent variables, N is equal to number of observations. To examine whether the independent variables jointly explain the dependent variable significantly, we compare the explained and unexplained variation under two different models, the unrestricted model and the restricted model. The unrestricted model is the full model containing all explanatory variables, whereas the restricted model imposes certain restrictions on coefficients under the null hypothesis, usually setting them equal to 0. If the unrestricted model produces much higher explained variation than the restricted model, it indicates that the imposed restrictions are not valid. The higher the F-statistic, the better it is for the model. The formula for F-statistic is SSE of restricted model minus SSE of unrestricted model divided by Q whole divided by SSC of unrestricted model divided by n minus k minus 1. Here Q means number of restrictions imposed. SSCR minus SSCUR measures how much error increases after imposing restrictions. If the increase is large, the restrictions hurt the model. When divided by Q, it gives an average increase in error per restriction. SSCUR divided by n minus k minus 1 gives average normal error of unrestricted model. The whole ratio of F-statistic compares extra error caused by restrictions with normal model error. If restrictions create much more error than usual error, F-statistic becomes high, and high F is good for decision making because it tells us restrictions are wrong. Follow for upcoming videos.